Oh, this one's very interesting. This one's dealing with, I believe it's called like bulk modulus or something along that nature. It's a very funny little symbol. This is problem number 21. And we are given temperature is 20 degrees C. The delta P, pressure increase, is equal to 44 MPa. We want to find percent density increase. And we're told to take this E sub V is 2.2 GPa. So first thing I want to do is I kind of want to convert this into GPA. So if I go to the calculator and I go to apps, if I go up to Sci Tools, or I just do apps 0, we can go to unit converter, and we can go to SI prefixes, and we want to go from, I think it's maybe big M, one of these into giga, right? Yep. That's going to be e to the negative third. So this is going to be 44 e to the negative 3 GPa. Okay. Now, if we remember, the equation here is equal to, well, one way you can put it is delta P over change in pressure, change in density, over density. Now, we are told it's also water, so I guess we're given that it's H2O. So we can find what is H2O at 20. That'll give us our normal density. So yeah, rho W is equal to 998.21 kilogram per meter cubed. And we remember the change in, should be change in pressure. Okay. Oh, this is what we're finding here. Okay, perfect. So we know this. Okay. We know the change in pressure. And we know this. We know everything but one. So it should be relatively simple from here. It's just going to be manipulating this equation. So we can rewrite this as this equals this. I'll try to do it one step at a time. I have it written on my note sheet in another way. Yeah. That makes more sense to me if I do it that way. So what we can do is we can see this as one unit and this as one unit, and we can just make them trade spaces, which is really intuitive. So let's do that real quick. So now we have delta density over density equals delta P over EV. And now all we need to do is multiply this side by the density. I want to say water just to specify. So now we're left with the change in density, which is what we want, is going to be equal to the change in pressure over the bulk modulus, I believe that's what that is, and then the density multiplied by the density of water, which this is going to be equal to, you can't see down there, which is equal to, well, let's see, change in pressure is 44 e to the negative 3 GPA all over 2.2 GPA times 998.21. Let's do this really quick. I'm getting 19.96, and what would the units here be? Pressure, or no, its density is going to be kilogram per meter cubed. No. I have it written wrong right there. This is change in pressure. I'll have to check that unit. Check that unit in a bit. Hey, hold on. Change in density. Okay, we have this. So now what we want to know is the percentage. So this is going to be, I think this should be, this, divide that by, or it should be the other way around, right? 999, 98.21. Percent increase. Oh, okay. So you take this 998.21 and you add this. So we've got this. Now this divided by 998.21. Yeah. So this is kind of correct. So this is essentially going to be our 998.21 plus our 19.96 all divided by 8.21 is equal to 1.02 or plus 2%. And that's our answer right there, is a 2% change. Or a 2% increase. Yeah, another problem done. Cha-ching.